As you can see, here I have considered a wave. The upper part here in the positive y direction, this is crest of a wave, and the lower part is known as the trough. There are different parameters that defines a wave, and these parameters are wavelength, amplitude, frequency, velocity, time period, and wave number. Now let us see what are these parameters one by one. Wavelength. Wavelength is the distance between successive crests or troughs. So here in this particular wave diagram which I have considered, I have two crests here. So the distance between these crests, this represents wavelength. So wavelength is represented by symbol lambda. It is nothing but the distance between successive crests or the troughs. And the SI unit of wavelength is meter. There are other units which represents the shorter wavelength. It can be nanometer or angstrom. So we have 1 nanometer is 10 to the power minus 9 meter. 1 angstrom is 10 to the power minus 10 meter. The second parameter that defines a wave is frequency. Frequency is nothing but it is the number of oscillations per unit time. It is represented by the symbol nu, and the SI unit of frequency is per second. In order to honor the scientist Hertz who has invented this term, it is represented as Hertz. Amplitude is the distance between the mean position and any of the extreme positions. It is represented by A. So this is the mean position. This is an extreme position. So the direction of wave along x-axis is mean position, and this is the extreme position. So the distance between the mean position and the extreme position in any directions gives us amplitude. The SI unit of amplitude is meter. Wave velocity is represented by v. It is the distance travelled by a wave per unit time, and the SI unit of wave velocity is meter per second. Speed or velocity is given by the formula distance upon time. For a wave, speed is denoted by v, and the distance with respect to wave is nothing but its wavelength. Divided by time, and the relationship between speed, wavelength and frequency is v is equal to wavelength is lambda divided by its time period is t. Also we have another relation between time period and the frequency as 1 by nu. So we can write this as lambda into nu. Velocity is the product of wavelength and frequency. Time period for a wave is the time taken to move through one complete oscillation. Wave number denoted by nu bar, it represents the number of wavelengths per unit distance. So nu bar is the reciprocal of wavelength. Hence the SI unit for wave number is per meter. So wave can be defined by all these parameters. These formulas which relate wave number and wavelength as well as speed of a wave with its wavelength and frequency is important. Also, you need to remember that light travels with same speed in vacuum and that speed is constant. It is represented by c, which has a value of 3 into 10 to the power 8 meter per second. C is velocity of light in vacuum. It is constant, given by 3 into 10 to the power 8 meter per second. Let us discuss a few questions on how to find the frequency or wavelength for a particular radiation of electromagnetic spectrum. The question is, the ViVid Bharati station of All India Radio Delhi broadcasts on a frequency of 1368 kHz. Calculate the wavelength of the electromagnetic radiation emitted by transmitter. Which part of the electromagnetic spectrum does it belong to? From the question, we can write the frequency of radiation represented by nu is equal to 1368 kHz. We know that the SI unit of frequency is Hertz. So let us convert this kilohertz means it is 10 to the power 3 Hertz. So converting it 1368 into 10 to the power 3 Hertz, or the unit is per second. So this is 10 to the power 3 per second. They have asked us to identify which part of the electromagnetic spectrum does it belong after calculating wavelength of the electromagnetic radiation. So in order to find wavelength, we have the formula lambda is equal to c divided by nu, where c is speed of light in vacuum and it is 3 into 10 to the power 8 meter per second. Now let us substitute the value. C is 3 into 10 to the power 8 meter per second. Frequency of the radiation is 1368 into 10 to the power 3 Hertz or per second. This unit cancels, and after simplifying the remaining terms in the numerator and denominator, we get wavelength as 219.3 meter. And radiation of this wavelength that corresponds to the radio wave region of the electromagnetic spectrum. Second question, the wavelength range of the visible spectrum extends from violet to red. Wavelength is given 400 nanometer to 750 nanometer. Express these wavelengths in frequencies. In terms of hertz, they have also given 1 nanometer is 10 to the power minus 19 meter. So I can write wavelength for violet light is 400 nanometer, which is equal to 400 into 10 to the power minus 9 meter. And the wavelength for red light is given. It is 750 nanometer, which is equal to 750 into 10 to the power minus 9 meter. We need to express these wavelengths in terms of frequencies. So first let us examine what is the frequency for violet light. So let us find it out first. Frequency of violet light, it is calculated by using the formula nu is equal to c by lambda. We know c has a value 3 into 10 to the power 8 meter per second. Substituting, c is 3 into 10 to the power 8 meter per second divided by wavelength for violet light, that is 400 into 10 to the power minus 9 meter. Upon simplification, we get 7.5 into 10 to the power 14 Hertz. So this is the frequency corresponding to violet light of the wavelength 400 nanometer. Let us calculate the frequency of red light in the similar way. So we have frequency is C by lambda, it is 3 into 10 to the power 8 divided by wavelength of red light, that is 750 into 10 to the power minus 9 meter. Upon simplification we get 4.0 into 10 to the power 14 Hertz. So I can write the visible spectrum ranges from 7.5 into 10 to the power 14 Hertz to 4.0 into 10 to the power 14 Hertz in terms of frequency. And this is how you can solve this particular problem.